Thank you, everyone. Sorry about the technology is hard. And I know it's really stuffy in here. It's the last talk before the closing keynote, and it's Friday. Please bear with me. So as Rafaela mentioned, I'm Grace, currently Senior Software Engineer at Yammer. I work in London right now, but I started off in San Francisco, and that kind of plays in a little bit. And today I'm here to talk about herding cats. Why particularly herding cats? Partially because it's the internet loves cats, really. But mostly because herding cats is one of the hardest things that you can possibly do. I have a friend who has this story of when he was living with a roommate in uni. His roommate had 2 cats, and my friend would play this game where he would take a laser pointer and he would try and get one of the cats to sit inside of a bookcase, and then while that cat was still sitting in the bookcase, he had to get the other cat to also go into the bookcase. You can imagine, cats don't exactly stay put in any one place, especially when the laser pointer is gone, so it's not exactly an easy task. But this isn't a story about impossibilities. It's about being able to train teams and help them learn new tricks for dealing with very difficult problems. In this case, being on call. So let's rewind first, all the way back to the year 1 BC, before cats, not before Christ. In the beginning, there was only darkness. But suddenly, out of this darkness, there came a sound. And excuse me, there's no audio, but please imagine. Oh, I think someone's phone went off. Imagine that to be a pager sound. So when I started working at Yammer, we didn't really have a concept of on-call. I'd heard lots of stories about this fabled team at other places where people had to carry around pagers or modern times, mobile phones, with them at all times, just in case something went wrong with the production environment. So Yammer didn't really have this kind of role. Well, sort of. There was one person who was on call all day and all night of every day of every week for the rest of his life. Not quite. It was close, though. So everyone was around to always help, of course, but eventually the team became so large and the entire environment was so unwieldy that it was really unreasonable for us to expect this one person to be on call for basically everything. And we kind of knew this deep down inside, except that nobody really had the guts to say this out loud. But why not? Why didn't we want to help out this poor engineer who had the entirety of Yammer on his shoulders? Well, at the time, we were pretty confident and kind of thought more or less, and I paraphrase here, we don't need to stick in on-call rotation. Our product is so good, it doesn't need a whole team to actually keep it up and running. In a word, that's all bullshit. As you would expect, eventually, disaster happened. It was a Friday, or for some of us, it was under the Thursday category, and we hadn't really slept much, so, somewhere between Thursday and Friday. And there was a massive production issue that occurred for some reason or another. And there was a handful of either very dedicated or probably insomniac engineers who were really struggling to actually get things back into a good state. And eventually, we had to call for help. And this is essentially how, roughly, the call went. Hi, sorry to be calling at this hour. I'm from Yammer, and I work with engineer's name. Can I please speak with him? It was pretty much exactly as awkward as it sounds. For a little bit of backstory, this engineer had just gotten back from his honeymoon, and it being 3 in the morning, he didn't answer his phone right away, so I think it was actually his wife who answered. So me calling at 3 a.m., his wife answering, it was awful. But so we managed to get him, we managed to wake him up. He came online, and after several hours of firefighting, Finally, we managed to get the production environment into a stable state again. But it was at this point kind of where we decided we can't keep doing this. This guy needs to sleep. So the decree was made. We should have an on-call team. Hooray, problem solved, right? Easier said than done. The first difficult thing that we came across was maths. At the time, we decided to put 4 engineers, or cats, to be the test subjects to iron out the entire process. Out of these 4, one of them was the cat herder, the tech lead. We had 1 monolithic Rails application and about 15, give or take, Java services, so 2 different stacks completely. And we basically had to take all of this and try and figure out how to best organize everything and split the responsibilities so that it didn't make everybody's lives miserable. And turns out the answer isn't easy, and for us, it just ended up with 4 very sad cats. This is a quick photo of the exact sheet that I was scribbling on to try to figure out how our scheduling should be so that, it didn't suck for everyone. But it turned out really, every option sucked. Another big challenge for us was learning to deal with acronyms. At the time, and actually still to this, I believe, acronyms are acronyms are a way of hiding meanings behind, just 3 simple letters. Why have letters when it's not that much more difficult to actually say the entire word? But we couldn't really avoid them at the time. They became bigger and bigger and bigger and bigger until we just couldn't avoid them anymore. So I'll quickly go over the main ones that we cared about, and I'll try not to use the acronyms for the rest of the talk, but I might slip, so apologies ahead of time. So the first one, MTBF, or mean time between failures. This is basically how often does your system fail? If obviously the shorter means worse. If your system fails less frequently, much better. MTTR, or mean time to recovery, is not exactly the flip side of the coin, but it's very closely related. It's basically when something happens, how quickly can you resolve it? How quickly can you get back into a known good state? SLA, or service level agreement. This sometimes I think is used synonymously with uptime. It's basically how often is your application actually available for your users to use. It's very important, so it's something that we always have to keep in mind. AAR, after action review. This one was used previously before we'd actually even started this whole process. We actually co-opted to use IR instead, incident report. They basically mean very similar things, which is, as it says, after the actual incident is resolved, you have to document it somehow and kind of explain to everyone involved, anybody who cares, what actually happened. And this is a lot. We were really confused. There was a lot we struggled with. So we focused our efforts on just the first 2 to begin with. So what mattered the most to us? Like I said, these 2 are not quite opposite sides of the same coin, but they are very closely related. Mean time between failures versus mean time to recovery. How often does your cat vomit on the rug versus how quickly can you clean up after it? And obviously there were various things that we had to consider. The first one being the rough business impact of each, which is the ones in gray. What we needed to do to achieve either of these goals, the ones in blue, what gains we would get out of improving on this one versus the other, obviously green. But also, obviously, neither are perfect, so there are bad things that we have to consider as well, the ones in red. But like I mentioned, they're not totally dependent on each other, but the SLA, or the uptime, does depend on both of these. And I swear this is the only formula. It's not really even a formula, but it's some official definition somewhere. But you can see here that it's not really a scale of having one versus the other. It's more like a range for both of them. And as one thing goes up, you don't have to necessarily go up in the other one. And in fact, it could actually go down. But once you're happy with how far you've improved on the first one, and it doesn't even have to be 100%, you can go and push the other one up as well. But whatever you do, obviously, you need to stick to the important left-hand side of the equation, your availability. Next, we had to look at those incident reports. A long time ago, like I mentioned, there was mention of, some people had to write up these after-action reviews after shit hit the fan, but getting engineers to write documents, especially long paragraphs of descriptive text, and especially when it's possibly customer-facing, cats, herds. So we had many options that we looked at, first being Google Doc forms. If you're not familiar with how the results come out of Google Docs forms, Google Forms, is that it basically collates all of the answers into a spreadsheet. And this really made those reports kind of hard to read, especially if the responses to the form were long text. On a spreadsheet, it just ends up really hard to read. Yammer also has a rich text editing feature called Notes. And obviously, since we use Yammer for our day-to-day communication, this was kind of the natural choice where we said, hey, we're talking on Yammer anyways, why don't we put all of our documents into Yammer in Notes? The only problem with this, though, is that they are hard to analyze. While you can attach notes to any conversation or message thread, there's not really a good way to go search for all of the different notes that you've created. So that was kind of a bust, too. Lastly, we use JIRA for most of our bug tracking and workflows. And while it's not exactly a very standard use of JIRA to write incident reports in it, it turned out to be kind of the only solution that really worked for us. So we went with that. And here's another real-life photo of how we were actually trying to figure out which things we needed to track in our JIRA tickets once we decided to go with that. And you'll notice there's a lot of possible form fields. And obviously, at the time, we thought they were very important, that we had to track all of them. But over time, we eventually realized that people just kind of naturally stopped filling out certain ones. And so those, by nature, just became optional fields. Of course, the main ones, though, still exist to this day, and those are the ones that we really care about. Things like start time, end time, summary, root cause, any follow-ups, those kinds of things. So, with all this, we thought, hey, we're actually starting to get used to this. Well, not yet. At the time, the way that we did projects made it such that whenever we created new services in our microservice architecture, we dumped them. Once they were done, we kind of dumped them into the pool with all of the others. And this meant basically that the number of services grew faster than the number of engineers who maintained them. More technologies also means more toys for our cats to play with. For example, at the time, I believe we had at least 4 different data stores on top of all of the service we had. So imagine if you took a bunch of yarn balls and fake mice and threw it on the ground, and then you let your cats loose on them. It would be mayhem. And this is kind of similar to how it felt. So despite all of this, we also tried to rotate our engineers through different projects so that we prevent expertise, or as some people call them, silos. And it made sense at the time. You want your cats to play nicely with all the different toys and kind of share with each other. But unfortunately, not every single cat is going to be able to play with every single ball of yarn, or even know that other balls of yarn exist. So unintentionally, silos could actually appear even when you try to prevent that from happening. Another side effect of that is that you kind of get no clarity on who's responsible for what. After the cats are done playing, they'll just like saunter off and let someone else pick up after them. Lastly, and most importantly, and we didn't really have a good answer for this, and we might not still have a good answer for this, burnout. This is when your engineers basically just feel overwhelmed, stressed out to the point where they just can't focus on their day-to-day work anymore. And after all this, we decided, you know what, these 4 engineers at the time, we can't keep making them do this. They actually need to get some sleep as well. So after several months, we finally figured that our efforts had kind of gotten us to a point where we could actually roll out this process to the rest of the team. And obviously there were plenty of adjustments that we still had to make, and a lot of them were very much needed at the time. One of the first things that we did was split our responsibilities for on-call. The easiest distinction that we had at the time was, well, we have 2 stacks. We have a Rails application and we have Java applications. Cut it down the middle. Made sense, right? Another thing was, I should mention actually, all of the initial efforts had been taking place in the San Francisco office. So finally, we added the London office to the on-call rotation, which finally meant that we can actually sleep at night. Instead of doing 9 a.m. to 9 a.m. the next day, we can do 9 a.m. to, say, midnight or something, and then the London office can pick up from midnight to 9 a.m. in San Francisco time. It'll be daytime for them. It kind of worked out. But this also meant that with more people, we would have more people to actually train and make sure that they get up to speed and all the knowledge, obviously, about all the different services. And it's a lot to digest at once, especially when there's a lot of pressure behind, obviously, having to maintain these services throughout the day. So we had to make sure that we trained our people very well and have them both be open to helping anybody in an area that they might be more familiar with, while feeling that it's okay to approach anybody else who might be more knowledgeable in something else that they're less familiar with. This, honestly, is the hardest part. Think back to the parking the cats story. It's kind of the same thing, where you only have one laser pointer and multiple cats, trying to put them into a bookcase. It's possible, though, to get the entire team on board. You just have to be very persuasive, and I'll touch on that a little later on. Lastly, once everybody has been onboarded, of course, we had to practice. So we did drills, we did tabletop exercises, we did breakdowns, just lots and lots of practice. Now that everyone was on deck with being on call, though, there was a lot of other cleanup that we had to do. First thing, and most importantly, was we had to make sure that all of the alerts that we actually started generating were actually specific, or more specific, and had clearer steps to resolution. We also made sure to keep them all in source control so that we had some history of all the different changes, because we realized it's not exactly a matter of changing an alert one time and then it's good to go. Sometimes you have to kind of tweak it a little bit. You let it sit for a while. If it goes off again and it still seems wrong, then you have to change it again. So source control made sense to have all of these changes in, because it's basically like a configuration. And of course, it meant that it was more easily maintainable. In the meantime, while all of our engineers were busy doing their thing, they might not have time to do all of the documentation and those pesky incident reports and things. So we made the managers do them. The incident managers, in this case, also had to make sure that they could it was their responsibility to coordinate all the different engineers for all the issues that come up. Most importantly, they did the external communications with the teams that would have to tell the customers the bad news that our application is down and they might be having problems with it. Just like how You can't really tell a cat to go and talk, cuddle up with someone. Engineers probably don't exactly like interacting with their customers all the time, especially not about things that they might have accidentally broken. Besides, they're busy actually trying to fix the thing anyways. And I also mentioned briefly a little bit ago that we had to make sure that we documented clear steps to resolve all the issues that we had. So we went through all of the services that we had and made sure that their run books were clear and actually up to date, and where possible, that they actually had more or less a one-to-one of common alerts and very clear, like 1, 2, 3 steps on how to actually resolve them. We also had kind of a backup for this as well, because obviously if something were to happen to our GitHub Enterprise hosted instance somewhere, we would basically lose all of the runbooks. So we had to make sure that we had a separate repo of kind of a consolidated cheat sheet list of all of the runbooks, so that you can engineers could clone that down locally to their laptops, and then they can have it with them whenever they needed. As I mentioned, the last step especially is important to making sure that your mean time to recovery is the thing that you're improving. Obviously, the faster that you can actually resolve them, because all you have to do is do 1, 2, 3, it's going to be much better for everyone. So all these changes continued for a while, and we slowly began to hit our stride, obviously still continuously making adjustments as we discovered different parts of our process that didn't really work for us. And so my story now comes up to speed with the present. And you might be thinking, you've done all these things already. What's left to fix? Well, like any real problem, person or code-wise, there really is no end to things that you can do to improve things. And please keep in mind, from here on out, the things I'm talking about are obviously still in flux, because we're doing them right now, so take it all with a grain of salt. One of the biggest things and hardest things that we did was combine the two schedules that we had. As I mentioned before, we had originally split the responsibilities by Rails and Java services, but now that we had, at the time we had decided that, that basically means that people would have to be on call more frequently, because if there's only 5 Rails engineers, for example, versus 10 Java engineers, the rotations would get out of sync and it would be all weird. So we realized that by saying everyone would be responsible for all of the different services, you would actually have to be on call less frequently. So now, instead of having 5-week rotations, for example, you would have maybe 15-week rotations. So you'd only ever be on call like once for 1 week, and then 15 weeks later you'd be on call. That's several months, so hopefully that's enough time to kind of recover from if it's a especially difficult week. I'm sorry. So, and another part of this decision was actually the fact that we decided to unify the two teams. So instead of having our Rails and Java developers, we decided they're all basically doing services, so it made sense to combine them. And of course, since the teams were combined, it made sense to combine the on-call schedules as well. This is kind of the main intent of this was that we expected everyone to be able to develop and maintain all of our services behind Yammer, regardless of their primary programming language. So learning from mistakes and problems is also good practice, not just here, but any part of life, really. On top of the incident reports that we did, we also started doing postmortems and retrospectives, very similar to kind of Agile Scrum retrospectives. But we made sure to do them almost immediately after the incident, so it was still fresh in our minds. In these retrospectives, we made sure to focus on just a few key questions. The what, basically the timeline. What happened in what order? And this is the very first thing that we asked so that we can kind of get a clear understanding of basically just getting the facts straight. The where which geographical area this happened, or possibly which customers in what part of the world were affected. This kind of gives us a little bit more clarity into possible root causes as well. The who is obviously who had to get involved, which engineers were on call. Did they have to actually pull in anybody else because they were not so knowledgeable in this area? Were those other engineers easy to, were they able to quickly respond? Those kinds of things. The why, obviously the root cause of the issue, because that's kind of the thing that we want to get into. But I think the most important thing that we look into is the how, which is how can we prevent this from happening in the future? So once we get the root cause, we know what went wrong, now we have to make sure that it doesn't happen again. However, beyond all of these 5 questions, the actual most important thing is that we didn't make this a blame game. It's the purpose of these retrospectives was not to point the finger at anybody, because in such a massive system, really, a small change here could mean disaster all the way over there. And it's a mistake that anybody could make, and we don't try to put that pressure on any one person. The idea is that it's a collective ownership of problems and a collective ownership of the efforts to fix these problems. We also made sure to do weekly handovers first thing Monday morning in both the San Francisco office and the London office. Basically, what would happen is the engineers who were on call the previous week would get into the same room as the engineers who were coming on call this week, and they would just tell them what exciting things might have happened in the previous week. If there's anything ongoing that they need to know about, obviously, because that's probably something that they'll have to deal with during their week, those kinds of things. We also make note of all of the main alerts that we've got that the engineer had gotten during the previous week, and we keep track of this week over week so that we can see if there's any trends upwards of certain alerts on any specific service. And basically, this is kind of our running tally of what areas we need to focus on and what needs to be fixed right away. And also, we made sure to check for all of these alerts, if there were any runbooks missing or if there was any information missing regarding these specific things. And because time zones are hard, we had to make sure that there were on-call tech leads in both the San Francisco and London offices so that they can hand over things to each other, because it's obviously really difficult to get engineers to be in meetings at either 5 p.m. or beyond in London and 8 a.m. or earlier in San Francisco. So having just one lead in each of the offices doing most of the communication across made it much easier, and obviously took a lot of pressure off of the engineers so they can actually go and continue on with their normal day-to-day work. So, and aside from the weekly reviews and the postmortems, in London we also started a side effort to make sure that the engineers are actually feeling like their time on call is actually valuable and that they're helping more than not. These were completely optional, but engineers coming off call were recommended to fill out a survey, and the questions were the same every single time, so they knew what to expect. And basically what we tried to get out of this was to see how their mood was before and after going on call, and if there's anything that seemed to have gotten worse since the last time they were on call, and making sure that we're actually following up on any of those things that might have been happening over a long period of time. We also asked some other things like how they felt their partnership with their primary or secondary person on call was, how well coordinated they felt, how they kind of carried each other for commute times or all those kinds of things. And it allowed us to get kind of an on-the-ground perspective of all the problems that we might have missed, because obviously doing weekly handovers, there's a lot of things that might not necessarily come up at the time. But most importantly, we made sure that the engineers felt heard. Their opinions matter too, obviously, and we didn't want anyone feeling like they were way overwhelmed or that they were on their own. And of course, we didn't want anybody to feel burned out. Of course, though, the biggest problem that we had is the fact that we just kept having all these damn alerts. So we need to fix them, right? And we kind of narrowed them down to 3 different categories that we could focus on. First up on the chopping block were the noisy ones. These are alerts that were possibly configured wrong. Maybe there's a threshold that could be changed to fix it, or maybe the alert's not even necessary. So we got people to make sure that they cleaned up any of these kinds of noisy alerts. Flaky ones are slightly harder to deal with. These are the types of alerts that are like, they'll resolve before you actually get a chance to go look at it. Graphs might be spiky and you have no idea why. Or even people working on different projects that, on a specific service, for example, they might have been doing something and then forgot to tell the engineer, which is very bad practice too, but those are different things as well. And obviously, if there's actually an issue that is underlying these flaky alerts, we obviously had to spend a little more time to dig further into them. And lastly, of course, we had the real alerts. They're slightly better. Not in that we had real alerts at all, but in that hopefully we had set up the alerts properly so that they go off early enough that we can be proactive rather than reactive. And while we don't have this yet, we do plan to set up sort of an initial line of automated defense for these real alerts, such that, say an alert triggers and it's an actual real one, again, we can be proactive. Maybe there'll be an automated script that runs to go through the main steps that usually seems to resolve this type of incident, and then if after that it doesn't actually resolve, then we'll pull in an actual human being. Then we can save quite a lot of engineer time. But again, we're not quite there yet, but we hope to get there very soon. And you'll notice a lot of these things focus very much on the mean time to recovery, but they start having kind of a hint of mean time between failure as well. Being proactive obviously means you won't even have a failure, so your mean time between failure improves. So all of this probably sounds completely insane, and we actually probably still are really far from where we need to be or where we want to be. But we've come quite a long way, and at least we've seen enough to know better what path we need to take to actually get to our end goal. I mean, hell, before we didn't even really have an end goal, but now we do. So the end goal for us is eventually we want to get to a point where we only ever get 1 alert per person per day at maximum. So that's roughly 7 per week. And obviously this might mean that our rotations could improve as well, because we could have people be on call less often because you don't have to sacrifice your entire week. And obviously on the side, it means that our system is more stable. Fewer alerts means healthier system, which is obviously good for both the business, because users are more likely to be happy with a site that's working close to 100% of the time, and obviously because the engineers don't get interrupted as much. And as we continue building out our microservice architecture and continue adding more and more services, by making sure that we have fewer alerts overall, we can actually draw new ownership boundaries and have people be on call only for those services that they own. So instead of the old model where we went with just technology stack for Rails versus Java, we could have, say, a messaging team that would only have to deal with the services related to messaging. This meant that while there is a little bit of siloed knowledge and expertise, at least their response will be faster because they actually know what to do with these different things. And again, once we have this kind of thing in place, maybe it means that we could even put these teams on call 24/7 for these different services. And while that may sound terrifying at first, if you think about it, with the goal of just one per day at most, it's actually not even that bad. The likelihood that any one engineer actually gets woken up in the middle of the night is significantly lower anyways. And besides, its magnitude's better than what we have right now. It's little kitten steps. And basically up until now, all that we've been doing, all of our efforts have been put towards cutting down our mean time to recovery. Now, as I mentioned before, I think it's time that we push the slider up for our mean time between failures. So these goals reflect that. And of course, maybe someday we'll get to a point where the world is just a box full of kittens. But why? Why are we going through all this trouble? Why put all this stress on all of our engineers? Isn't on-call just for ops? No. And I could really end this here, but I'll go into a little bit more explanation, so if there's any one takeaway that you have out of this whole thing, it's this. It's not really one team's responsibility, but the entire organization's responsibility as a whole to move towards being more proactive than being reactive to any incidents. This is the Wikipedia definition of what DevOps means. A lot of times I've heard people describe DevOps as a team or a role, but I don't believe that's quite, DevOps doesn't mean that in my mind. So this is what Wikipedia says, and I didn't put the actual quote here because it's Wikipedia. So, DevOps is a culture, movement, or practice that emphasizes the collaboration and communication of both software developers and other IT professionals while automating the process of software delivery and infrastructure changes. It aims at establishing a culture and environment where building, testing, and releasing software can happen rapidly, frequently, and more reliably. So you can see how a lot of that kind of seems to boil down to us putting the responsibility of being on call to all of our engineers and not just one specific team. Overall, I feel as engineers, we all feel this sense of responsibility for the code that we ship. And hopefully, we share that with all of our colleagues. We also take pride in the code that we write, in knowing that we deliver not just value to our customers and therefore our business, but also quality. And if we want to achieve that, unfortunately, we sometimes need to go through a little bit of pain. After all, no pain, no gain. None of this is easy, though, and that's kind of why we've taken a very long and convoluted path to get to this place, where we have some form of process, and it kind of works for us now, but it might not soon, and we'll have to change things again. And we'll continue working on it because, well, nothing is perfect. And we all need some direction once in a while, and we all need to be herded. Thank you very much for taking time to listen to my story.